Rationalizing denominators. We're going to do a couple of examples on rationalizing. And what this means is anytime we have a square root expression in the denominator, this is not acceptable. Okay, we have to get rid of the square root in the denominators. Rationalizing means that we take this number, which is an irrational number, and we want to make it a rational number. So that's why we say rationalize the denominator, which means make the denominator a rational number. So whenever you have a square root, a third root, a cube root, a fifth root, whatever n root you have in the denominator, we need to get rid of it. And how we do that when we have this, for example, what we do is we multiply this expression by a disguised 1. I call it a disguised 1. I want to multiply it by 1 because I don't want to change the value of the original expression. So this will remain the same value as long as I multiply by 1. But I'm going to use a disguised 1, and that disguised 1 is going to look like this denominator. I will use this denominator to multiply the numerator and the denominator by. So notice the square root of 5 over the square root of 5, this is equal to 1. So I'm really multiplying by 1. It's only a disguised form of 1. And this is what happens when we have fractions. We multiply numerator times numerator. Now when we multiply a number times a radical, we're multiplying the number times the coefficient of the radical. So 7 times 1 is 7, and then square root of 5. Okay, if we come over here to the side, it's like multiplying 5 times x. You multiply 5 times the coefficient of x, which is 1. 5 times 1, that gives you 5x. Okay? When I have 7 square roots, 7 times the square root of 5, let me erase that 1 second. I wrote the answer. When we have 7 times the square root of 5, that means I have square root of 5 7 times. So I'll have a square root of 5 plus another square root of 5 plus another square root of 5 plus another one, 7 times plus another square root of 5, like that. And that equals 7 square roots of 5. Okay, so 7 times the square root of 5 is 7 square roots of 5. That's the numerator. In the denominator, I have square root of 5 times the square root of 5. When I multiply radicals, let's go over here to the side. When we multiply radicals, we use the radical product property for this. And what that property says is that if I have the square root of a times the square root of b, that is equivalent to having the square root of a times b. So what that product property says is that I can, if I have separate radicals and I'm multiplying them, as long as I have the same index, notice that these both are square roots, as long as I have the same index, I can join them together inside the same radical. So for this example here, I have the square root of 5 and the square root of 5. I can use the product property and write 5 times 5 inside the same radical. And that becomes 7 square root of 5. This becomes the square root of 25. And this is what you get as your final answer. Notice, very important here, notice that my denominator is no longer a square root. Now it's a rational number. Okay, it's a 5. And also notice that when I did square root of 5 times square root of 5 and I used the product property, I could say this is square root of 25, but I could have also said that this is square root of 5 squared, right? And then this cancels out with the index, and you get 7 square root of 5 over 5, because remember that square root of 5 squared is the same thing as 5 and 2/2, which is equal to 5. So you could do this or do this. It's the same thing. You still get the same answer. And we've rationalized the denominator. Okay? Now I'm going to do another example. Here's example number 2. And in this case, I have 2 over 3 plus the square root of 6. Now, I cannot use the same tactics that I used in the previous example where we multiplied the numerator and the denominator by the radical that's in the denominator. If we do that here, it's not going to work. We're not going to be able to get rid of the square root of 6 if I do that. And I'm going to show you. This is not what you're going to do, but I just want to show you that it does not work. If I use the same tactic as I did in the previous example, I would get a numerator of 2 square root of 6, and then in the denominator I would have to multiply. I would have to multiply 3 times the square root of 6, which is 3 square root of 6, plus, and then 6 times the square root of 6, which is square root of 36. Okay? And if I simplify this, I get 2 square root of 6 in the numerator, and in the denominator I get 3 square roots of 6 plus 6. And this would be your final answer. And notice what happens in the denominator. Since these two terms are not like terms, I cannot add them. And also notice I still have a radical in the denominator. So doing this trick here does not help me at all rationalize the denominator. So this isn't going to work for this. Whenever you have a sum or a difference involving a radical, we need to multiply by the conjugate. And here's what the conjugate is. The conjugate. If your denominator is 3 plus the square root of 6, your conjugate is going to be 3 minus the square root of 6. If you have 2 minus the square root of 5, the conjugate is going to be 2 plus the square root of 5, okay? And that's what you're going to use to multiply the numerator and denominator by to be able to get rid of the square root that's in the denominator here, okay? So let's do this with this problem. I have 2 divided by 3 plus the square root of 6. Now I'm still going to multiply by 1, but this 1 is a disguised one, and it's going to be disguised as the conjugate of this denominator. So the conjugate of this denominator is 3 minus the square root of 6, and I multiply the numerator and the denominator by the conjugate. Notice that 3 minus square root of 6 over 3 minus square root of 6, that equals 1, okay? So I'm really multiplying by 1, but it's disguised. Now, this is a binomial. This is a binomial. This is a binomial. This is a monomial. Now I'm going to multiply numerator times numerator. That means I have to multiply 2 times 3 minus the square root of 6 in the numerator. And in the denominator, I'm going to have 3 plus the square root of 6 times 3 minus the square root of 6. Okay? In the numerator, I'm going to use the distributive property. I'm going to multiply 2 times 3, and then I'm going to multiply 2 times negative square root of 6. Let's do that first step. 2 times 3, you get 6. 2 times negative square root of 6, you get negative 2 square roots of 6. You're done with your numerator. In the denominator, we have a product of binomials, so we need to use FOIL. Okay? FOIL. That's first, outer, inner, last. Whenever you have a plus b times a minus b, you get a times a, which is a squared, minus b squared. And this is the simplified form. You could go ahead and do FOIL and you're still going to get this last answer. You would do a times a, which is a squared. Then you do a times negative b, which is negative ab. Then you do b times a, which is plus ab. And then b times negative b, which is minus b squared. And notice that these two cancel out and you get a squared minus b squared. So whenever you see a plus b times a minus b, this is going to be your result. It's going to be the square of the first term minus the square of the second term. In this case, I have a plus b, a minus b. And it's a product. So I know that the answer to this denominator, I'm going to write it down here, is going to be this first number, that times that, we already know is equal to that first number squared minus the second number squared. So my first number squared here, in this case, is 3 squared, minus that second number squared, which is square root of 6 squared. Okay? And that is going to equal 6 minus 2 square root of 6 over 3 squared is 9 minus, and the square root of 6 squared, let me go off to the side a little bit here and explain this. Square root of 6 squared, that's the same thing as saying square root of 6 times the square root of 6, which is the same thing as the square root of 6 times 6, which is the same thing as the square root of 36, which is 6. So this is equal to 6. So the final answer looks like this. There you go. Now we can simplify 6 over 3 and have a 2, and then we can keep it. We can go one step further here. But if you leave your answer like this, it's fine. But we can go one more step. 6 minus 2 square root of 6 over 3. This is equivalent to writing 6 over 3 minus 2 square root of 6 over 3. It's like separating this fraction. This is equivalent to that. And 6 over 3 is equal to 2, and then minus 2/3 square root of 6. Okay? So these two answers are equivalent. And that's how you get to rationalize your denominator using the conjugate, okay? And using this rule, the difference of squares. Okay, whenever you have a difference like this is going to be your answer. It's going to be the square of the first term minus the square of the second term. And there you have it. I'm going to do one more example in another video, maybe 2 more examples. I'll see you in the next video.